the last video today, C.4, exercise questions set number 2. Yeah. In this part, I give you 2 examples. Yeah. The first one, given a polynomial like this. Here you can see the highest term, degree 5. Yeah. Then, to evaluate the minimum number of multiplications that one needs is these options. Yeah. After we learn the Horner's rule, then we know how to do it. Yeah. If you do not know the Horner's rule, think about it. It's very likely you will select the last one, the more, 6 or more. Yeah. But after we learn the Horner's rule, then we know the highest degree number. What's that? Highest degree number, m equals 5. And we know if we apply the Horner's rule here, yeah. So direct application of Horner's rule here, then we can get the number of multiplication is this number. So then that's the option C. Yeah. But remember, when we apply the Horner's rule, the polynomial usually is a pretty general formula. So that means usually there is no special structure. So it's a, pretty general case. Yeah. So if you can look at the coefficients here, can you see any pattern? Right? So it looks like no obvious pattern here. Yeah. But the reason I mentioned this one is if the coefficients follow some special pattern, then the answer could be different. Yeah. So here, I just raised the question. If the coefficients follow some special pattern, okay, then the answer could be different. All right, could be different. Okay, why? Yeah. So here, we may need to use another new technique. At this point, I have not covered that technique. Yeah. So I like to delay this question until we cover that technique. So we will cover that technique soon. Yeah. So we delay the answer of this question sometime later. Yeah. Yeah. Special pattern. Yeah. What kind of special pattern? So we will see that. Yeah. All right. Yeah. This is the first example. Yeah. The second example. To evaluate a polynomial, general case. Okay. The format is a general format. Yeah. For some positive integer n, the number of multiplications is always greater than the number of additions. Here we need to look at the whole statement. Always. The meaning of this always here, no special case. It is always true. There is no counterexample. Always true. If if that is the fact, then you choose true. In other words, if you can find a counterexample, the statement is not true. Okay? Yeah. So if there is a counterexample, then it is not true. Okay? The question is, can you find a counterexample? That's the hard part. The counterexample, you only need one counterexample. One. You do not need many, only need one special example. That's enough. That is enough to make the whole statement false. All right. Here, in order to find a counterexample, we can use special coefficients. We're allowed to use special coefficients. Special example corresponds to special coefficients. So we are allowed to use special coefficients. Okay? Yeah. All right. So that means you can consider P of x equals 1 plus 2x plus x squared, right? Can you use this special example? Right? Yeah. It equals 1 plus x squared, right? 1 plus x squared. Okay? All right. All right, so here, look at here. The number of multiplication always greater. Yeah. Then the number of addition, not greater, right? Oh, yeah. So actually, yeah. So here, number addition 1, number multiplication 1. Yeah. So same. But if we use Horner's rule, equal, right? Yeah. Yeah. So we do not need to, if we use Horner's, yeah, this is another example of Horner's rule. If we just use Horner's rule, number of additions equal number of multiplications, right? Multiplications. Yeah, not greater. Yeah. Even we do not consider the special case, right? Yeah. Because Horner's rule for the general case. For the general case. No need to consider special case. Special case also okay. Yeah. So that logic is fine. That logic is fine. Counterexample special case is fine, right? Yeah. But we have another way to answer this question. Because if we use the Horner's rule we just learned, we can answer that question, even for the general case. Equal, yeah. So always greater, that's false, right? So B is correct. Yeah. All right. So that's 2 examples. All right, so let me complete 4 videos of part C. Yeah. All right.